So let's go ahead and get started. So R, why now? So what is R? Well, we've already talked about this a little bit. R is just a programming language for statistics. If you've never worked with it before, that's all it is. So it's a way of doing statistics, but in a programming-like environment. So as opposed to another application where there's a lot of mouse clicking, everything you do in R is by typing stuff in. It is freely available and very, very widely used. It's an incredibly popular programming language. The other nice thing about it is there are many, many user-created packages and libraries to handle specific tasks. So if there's something that you have to do that sounds really annoying, odds are somebody else has already had to do it, and maybe somebody else has already written some packages that will do all that hard work for you. All you have to do is download them and use those functions, okay? So it was created by Ross Ihaka and Robert Gentleman, and it's based on the S programming language by Bill Chambers out of Bell Labs. The very first version was in 1992, but the first real stable version was in the year 2000, a very good year. Also, it's Power BI's new favorite subcontractor. So there are a lot of jobs that R might be better at than Power BI. Because I mean, Power BI is fantastic, we all know it, we all love it, but it's not a statistics package, right? R, by contrast, is. So there are certain things that are sort of statistical in nature that R might do a better job at than Power BI. So now Power BI can have R do these jobs and send the results back to Power BI, okay? So I tend to think of it, I don't know comic books, so I'm sort of wading into sort of dangerous territory here. But you think about like Superman and Aquaman, right? So Superman like can do all this really cool stuff, but if there's a boat that sunk to the bottom of the ocean, Superman could do the job, but he's just gonna call Aquaman, because Aquaman's, you know, he's Aquaman, he can handle that. He's suited for that specific task, okay? They're both superheroes, they're superheroes in different domains, okay? So you might be asking yourself, I like the superhero references, they always go over real well. What kind of jobs are these wonderful things that you're talking about? Well, let's go through them. So, R and Power BI, the big and only three. There are exactly three things that you can do with R and Power BI. You can use R as a data source, you can use it as a transformation service, and you can use it as a visualization engine. The first two are very closely related. They are both about loading data into the data model, about getting data into Power BI so you can perform analytics on it. The primary difference, as you can kind of see here, is with a data source, it's always going to be your first step, right? And it has to be. So when you use R as a data source, you're going to write a script that tells R to go get data from some other third source, like a SQL Server or something like that, bring it into R, transform it, think about it a little bit, produce some results, and then those results get shipped back to Power BI as step one. That's using it as a data source. As a transformation service, it's pretty darn similar, but I think it's a little bit better. As a transformation service, it doesn't have to be the first step, it can be any step. And what that means is you can import data into Power BI, into Power Query, do a bunch of transformations on it, and then send that transformed data to R with instructions on what to do with it. R will transform it, think about it, produce some results, and send it back to Power Query, right? Again, the big difference being that it can happen anywhere along the process, as opposed to the first one where it has to happen in the first step.
Can I just pause you? Anything
yes.
done R as a transformation service or as a data source for you? You have, right? We just did. So,
yeah.
I partly I'd like to calm down, but partly I also, we have not, right, as we haven't used it in terms of, I haven't used it, we've used it third.
Rachel has a very important job in this presentation, and that's reminding me to breathe so that I don't pass out and fall over. Okay, so as a visualization engine is a whole different world. So both these first two, they're about loading data into the data model. The visualization engine is you've already got data in the data model. We want to visualize it. We want to show it to end users. So maybe we think that the visuals in Power BI just aren't going to cut it for this specific task. We could send data out to R, have it create a visual, send that visual back, and it pops up on a user screen, okay? By the way, are there any questions at this point? Yes?
Does you do a project using R and publish it to Power BI
I don't know about Office 365. It's not listed as a limitation, so it should work, but that doesn't necessarily mean that it always will. It will work as a service. So whenever you publish it, without getting too far deep into the weeds, when you're working in your local machine, you're going to install R locally, and so the requests are going to be sent to that local copy of R. Then when you publish it up to Power BI service, it's going to be running off of a server instance of R. So I don't see any reason why it wouldn't work, but again, that doesn't necessarily mean that it will. So it's kind of a non-answer. I apologize, I don't have a better one for you. Any other questions?
In that same, I don't know.
Yeah, sure.
Hear what the question was.
Oh, so if you, let me get the question right. If you publish to Office 365, Office 365 service, will the R script continue to refresh? Will it run into a problem? Is that the gist of the question?
Okay. Correct.
Yeah. Okay.
So I forgot the previous lady's name, but when you download a package and all that on your local machine, what's the sense likelihood of that package being sent?
Well, we're going to get to that. The good news is the bad news is not all packages are included. The good news is a lot of them are. So especially the ones we're going to talk about today, they're already on there. There's one that's not, that's on the short list of things to add. Okay. Any other questions so far? Okay. So let's dig into R as a data source. You click on Get Data. You click on Other. You click on R Script. And then you could get data using R. So I've got data source in quotation marks because it's not really a data source. This is sort of a point of some confusion. You're not getting data from R, or usually you're not getting it from R. R has to go get the data from some other third place, right? So you've got your data up in SQL Server, say. Power Query is going to send a script to R, and it's going to include instructions not only on how to get the data from SQL Server, which it's going to then suck in, it's going to include additional instructions on what to do with it once it's got it, okay? So then it takes the data from SQL Server, it transforms it, and then it sends the results back to Power Query. Does that make sense to everybody? Is that pretty clear? Question?
So it's kind of more like a preprocessor that you have certain things that don't work well with Power BI.
Absolutely. That's a very good way to think of it. In fact, you could think of it as a pre-ETL ETL, right? So, like before you ETL the data, you ETL the data. But, like, again, they're good at different things. They have different domains that they excel at. And Excel has its own domain that excels at. Sorry, I couldn't resist that one. Okay, so is this all making sense to everybody? Is this pretty clear?
Quick clarification.
Yeah.
You mentioned SQL Server, but are all the data sources available, like Oracle and DB2 and we can do all those?
Well, that's sort of the tricky part. I haven't looked at it like an exhaustive list, and I've heard that there are actually quite a few data connectors out there. But the thing is, you have to write your own, and that's what we're going to get to in the next slide. In fact, I'm just going to pause that and handle that in the next slide. Does that sound? Yeah. Okay. Any other questions at this point? Yes. We'll talk through a high-level example. Well, actually, we'll go through an example not of this one, but of the second flavor of it.
Could you just give us a real high-level example of this?
Oh, sure. Okay. So a high-level example is something that you might do. Let's say that you've got a data warehouse, right? And in that data warehouse, ostensibly you have customer data and you've got sales data. In fact, let's just stick with sales data because it's nice and easy, right? So you'd write an R script, and that R script would tell R to go get this sales data from the data warehouse, and then it would say, okay, based on this daily sales data, I want you to predict what sales is going to be for the next 2 months on a day-to-day basis. And then it's going to create that forecast. It's going to have days forward from now, and send that back to R. So if you want to create a forecast, that might be something you could do with it. Does that kind of make sense? Yeah. Okay.
Jerry had a question.
Yeah.
Might that R routine do something like a regression analysis on time and then just add some seasonality adjustment to that, doing a forecast?
Yeah. That's exactly the kind of thing it would do. Yeah. So like if you want, I'm not a statistician. There's a billion things you could do, but the two obvious big ones is you're going to try and forecast. You're going to try and predict the future. You're going to turn R into your magic 8-ball and look deep into the future and know it with certainty. Or you're going to try and see if you can't find some correlation between factors for things like sales, which is the example that I'll work through. Like say we know all this information about customers. Are there aspects about certain customers that sort of drive sales up or down so we can do better marketing? These are two big high-level examples. Everything still making sense to people? Okay. Am I breathing enough? Remember to do that, Rachel? All right, good. Good. Okay, so here's what it might look like. So you click Get Data, you click R Script, and you're presented with this. Except this stuff isn't written out for you, unfortunately. You have to write this yourself. And here's the tricky part about this step. You have to write your own extract. And in Power Query, extracting data from sources is really, really easy. You click on the button of the source that you want, you type in a few things, you hit OK, and you're basically done. Question? Okay, yeah. As opposed to here, where you actually have to write it. Now, if it's a really simple SQL statement, something like this, that's not too bad. You can do that. It's not really hard. But maybe the connector isn't so good. Or maybe the connector is kind of good, but the SQL is going to be really complicated, and it's going to take 5 or 6 hours to do, and you don't have 5 or 6 hours. Well, it might work, but it's a lot of additional work to sort of make it happen. Okay, that's the downside of this solution. All right, questions? Okay. So let's talk about, by contrast, R as a transformation service. What do I mean by that? I mean that there's a button in Power Query that has a big R on it. Okay, and you can call it to do transformations mid-query.
What does it stand for?
What does R stand for?
I'm sorry, that was supposed to be a rhetorical question.
Oh, Rachel.
Blew up on you.
Yeah, that's fine. Yeah. Okay.
So tonight we're going to define it as Rachel.
Okay. So, and I guess there's some new users in the audience. I'm sort of assuming an intermediate level, which is maybe unfair of me. When you're in Power Query, when you're loading data into your data model, before you create like measures like total sales and stuff like that, you're going to use I call it Power Query, but it's also called like get and transform data. And you're going to have a button that has like all the different transformations you can make to that data. So now we've got an R button on there, right? That's the sort of where the wheels hit the road, so to speak. Okay. So let's go through the flowchart of this guy. So this looks awfully similar to the other flowchart, and in fact, it is very, very similar to the other flowchart. But there's one key difference. Now, as opposed to the data going straight to the R engine, before it does that, it gets passed into Power Query. So Power Query is doing the extract of that data from the source. And maybe you clean it up a little bit, you make a few changes before you're going to send it off to R. And then when you're talking to R, you're not only sending off a script, you're sending off data along with that script. You're saying, hey R, here's some data, and here's what I want you to do with it. As opposed to, hey R, there's some data over there. Could you go get that and then do this with it? Does that distinction make sense to everybody? Okay, good. Good. All right. So here's what this one looks like. Again, awfully similar. You're not stuck with being the first step. So anywhere, anytime you want to make an R call, you just click on that big R button, and so it takes whatever data was here before. So here's this sorted rows table. It's going to take that sorted rows table and send it off to R. And it's going to call it dataset. Okay? So now when you're running your R script, you don't have to worry about extracting the data. All you have to do is worry about working with the data. Okay? Again, still make...
That brown box on the left is the steps that he's doing in Power Query. And the important thing is that this is happening low instead of at the top.
Right. Yep.
So are you finding better or you prefer to do it this way versus pulling it at source?
Yeah, and I'll talk about that. In fact, I'll just repeat it because it bears repeating. I would generally always start doing it this way because A, I know Power Query better, and B, I think Power Query's got a lot of good connectors for stuff that we're going to be interested in. And that way you don't spend 3 hours trying to get the data before you even mess with it. And we'll talk about that. This does involve additional step of it goes from source to Power Query then to R. So once you've got it tested, you might say to yourself, all right, now I know that it works. I'm going to speed that process up a little bit by spending that 4 hours to convert it from having an in-between step. Does that kind of make sense? What's that? Well, yeah, because it's got to pass the data to Power Query and then to R. So if you could pass the data directly to R, it's going to be faster, usually. You'd expect it to be. You'd run a speed test to be sure, but that'd be my guess.
Well, one thing that comes to mind, really, let's say that maybe the end result of your R solution, maybe you weren't even going to surface it in Power BI, right? But Power Query and Get Data is such a great tool for quickly connecting to the data and seeing what you've got and what you might want to do with it, right? Mm-hmm. So, even if you weren't going to build a Power BI solution, you might be motivated to use this approach to just really jumpstart your whole process for the data discovery, honing down what it is you want. Ultimately, you might say, well, okay, that was a useful exercise. Now I can more quickly deploy it just as a pure R solution. So,
cool. All right, so I'm going to put on my nerd hat for 1 second. Anybody that wants to plug their ears, feel free. I know. He raises an excellent point. If any of this seems a way too high level or something like that, don't worry about it. It's not a big deal. If this makes sense to you, you'll be like, ah. So when we're doing this, we're just calling an M function called, I think, r.execute. And it requires a script, what to do with the data, and it also requires a table. So in these instances, we're always porting the last step into R, we can create, like, you can imagine a table that's got a bunch of tables in it. Like, say you've got a table that's got a table of sales for March, a table of sales for April, a table of sales for June, a table of sales for July. You can run regressions on each one of those tables, right? Yeah. That's power. See? Yeah. I knew there were going to be at least 2 or 3 people in the audience who are like, woo, yeah. You have to write it by hand, or you like write it here and then sort of repurpose it, but you can do it. But you can do it. Okay, so I'm going to take my nerd hat off, put my regular hat, or less nerdy hat, well, some sort of hat back on, and we're going to sally forth. Okay, so, hey, Brian, those things sound very, very familiar. What is the difference between those two things? Well, I think I'm actually hearing that most people have kind of got it, but I built these fancy slides, so you guys have to look at them, okay? So, let's look at both of these solutions in depth. The top one is using R as a data source. The bottom one is using it as a transformation service. If you look at the top one, the data goes from the data warehouse directly to the R service. Statistics happens. A sales forecast pops out, and that sales forecast gets passed to Power Query, okay? In the bottom one, the data goes from the data warehouse over to Power Query. Power Query then sends the data to R service with instructions on what to do with it. R performs magic, creates statistics, creates a sales forecast, and then passes the results back to Power Query. Now, looking at this chart, you might be tempted to say, the top one is smaller, therefore it's better. That's not a crazy way to think about things, but here's the thing. These arrows are not drawn to scale by difficulty, okay? So some of these arrows are very easy. Some of these arrows are very, very difficult. In particular, that top left arrow up there is very, very difficult. Again, you got to write that thing by hand, and you're basically doing it in a notepad. So like if there's an error, good luck finding it. It's doable, it's just harder. So I would tend to favor the bottom solution, at least in terms of development, okay? So again, because I love charts, here's the same thing, just to really drive the idea home. As a data source, Power Query is sending instructions on how to get the data and what to do with it. R grabs the data, transforms it, and sends it back. That's a transformational service. Power Query gets the data, sends the data along with instructions to R. R performs those tasks on the data got passed and sends it back to Power Query. Just all like really crystal clear, because I know there's a lot of confusion between what are these two different things. Yeah.
Question, it sounded like you were talking like a lot of the difficulties with data source. So we're not having it be a data source, but having to write from SQL.
Yeah.
You write like Power Query, is there a way to get the SQL out of it? You kind of use Power Query as a tool to just plug it in.
Yeah, and I think.
So repeat the question?
Yeah, so the question is, so whenever you're working in Power Query, right, you can, if you write when you write a bunch of steps, you can right-click on the step and say, hey, show me the query that is being generated from this. And Power Query will basically show you, hey, I wrote this query to get the data. Can't you just copy that and paste it into your script? Sometimes. It's going to depend, right? And also, if you're working with SQL, you're probably lucky. If you're working with a different data source that's a little weirder or resty or something like that, might be a little trickier.
So if you were having like Excel spreadsheets, CSV, and
Yeah, it might be. I might be creating a problem that doesn't actually exist. It might not be that hard. But I like Power Query. I like working with it. Yeah, question.
So either process, when you're getting the data back, what does that file type look like? Or how does it come back into Power Query? And then where do you save that? Is it back to SQL server or
Sure, what does that look like? Okay, so the question is like, either one of these processes, I just draw this little chart here that says you get sales forecast data back. What does that actually look like? So in Power Query, you're going to write a step that says, go do some R stuff. The next step, you're going to have a table that has all of your what's called data frames in it. So a data frame is kind of like a table in R. So you're going to write a script that produces a lot of data frames, or at least one, right? And then it'll just have the table right next to it. You'll see it in a second. I'm going to demo it. But it doesn't persist anywhere. It stays in the model, right? You don't have to deal with it at all. It's going to load it straight into Power Query. Does that kind of answer the question? Fantastic. Okay. So again, I talked about this a little bit. The bottom one, I think, for me at least, always going to be easier to implement because you get access to all the different Power Query data sources. That for the stuff kind of work we do, I think it's just going to be easier. But the top one is a smaller pipeline, so it might be faster. So like if speed is an issue, you might consider, once you've got the bottom one working, seeing if you can't sort of convert it into the top one. Okay? Yeah. Yes. Absolutely. Absolutely. Yes. Okay. So, hey, Brian, you've been showing me PowerPoint for like 20 minutes now. My brain's going to explode if you show me another slide. Okay, let's go do something, huh? I'm going to hit escape. So let's go to Power Query, and we're going to show you using it as a transformational service. So I'm going to go here. I'm going to go to Edit Queries. And so right now I've gotten this data from a very fancy data source. This is Contoso. It's a company you guys might have heard of. It's fake data, is basically what I'm saying. Right now it's loading it from a CSV, but you can load it from anywhere. So we're using it as a transformational service right now. That's what we're demoing. So I've loaded the data from a CSV. I've done a bunch of steps to clean it up. I'm not going to show you them one by one because you'll fall asleep. But if we come down here, assuming my mouse works, come on. There we go. What we've got is this is the data that I'm going to send off. I'm going to do a regression analysis. I've got all these customers. I've got how much sales I got from each customer. And I have their income, whether or not they're married, and whether or not they're a homeowner. And I want to see whether those factors affect our sales. Because if they do, we might be able to target our marketing better. Does that problem, that business case make sense to everybody? Fantastic. Okay. So how does this darn thing work? Well, we click out here on our last step. We're going to go to Transform, and we're going to click on Run Our Script. Okay. So the first thing we're going to do is we're actually going to need something from a library called Broom. Again, you use libraries a lot. So again, libraries are sort of collections of functions that you can call, right? So somebody else has already done the hard work. So we're going to call this library called Broom, and we're going to use a function from it later on, okay? Another R. Oh. See, the trick with coding I found. What? I'm just testing you guys. I'm just testing you guys.
You have all performed attributes.
Yeah, absolutely.
And now we see the more difficult to do.
That's right. You have to be able to spell difficult words like library. All right. Okay, so first thing we're going to do, we're going to kind of do this step by step. We're going to create a linear model in R. And to create a linear model, it's pretty easy. You just type in LM for linear model. We're going to do a linear regression. If you know statistics, it's simple OLS, right? Okay, now again, because we're doing this as a transformational step, we don't have to write the part where we load the data. The data is already here. It's just called something called data set. So whenever we type in data set, what we're really saying is we're referring to the data that we're pushing into R, right? So we're going to perform a linear model regression on the data set data, okay? And what's the linear model going to look like? Well, we're interested in total sales, right? And we want to know how total sales is affected by, we're going to use the tilde symbol, which means sort of by, right? We want to know how it's affected by income. And you guys have to check my spelling, because apparently I'm not doing so good tonight. Whether or not somebody's married, and whether or not somebody is a homeowner. Okay, see, did I spell that right? Somebody want to call on it? Okay, so, what's that? Right here, good, okay, good. So, yeah, I'm terrible. All this pressure, now I'm thinking about it. Okay, so we've created this linear model, right, that does that thing. But the thing about R is that when you create something, it doesn't necessarily stick around. You have to put it somewhere, okay? So we're going to put that linear model in this object called model, okay? Now you may think to yourself, as I did, hey, I'm done. I'm going to click OK, and I'm going to get something back. And then you click OK. And R has a model in it. We're going to click OK. And we're going to get bupkis back, which is a technical term. Hold on. There we go. Hey, we have an empty table. Well, that's not very useful. So you might be asking yourself, where did the data go? I created this model. Where is it?
Predict the data of the world.
I know. Any guesses? Anybody want bonus points? What's that? Well, so here's the tricky thing. Is that model? So if you're used to working in Power Query or any kind of like stuff that we do, you think of a data set as a table. Like, and that's kind of the only real data set you ever work with. So we think that when we load our model into that model object, it's going to be a table, right? Or a data frame, as they call it in R. No, it's not. It's still a model. It's just a model called model. So we have to turn that into a data frame, right? And to do that, we're going to use one of the functions that we got from our Broom library. So we're going to type in tidy. We're going to type in tidy. That's the name of the function. And we're going to tidy up the model. We're going to extract the results from our regression, okay? And again, when we tidy it up, we've tidied it up. So if we do what we did right here, we're going to tidy up and then throw it away because we haven't put it in anything yet. We have to put it in something, okay? So to put it in something, I'm going to put it in something called output. Call it whatever you want to, not a special name. I'm just going to call it output, okay? We click OK. You wait. This is the most fun part.
Let's do this part stuff.
It's really tricky. I want to say it's like 2,500 rows. It's not huge. It's not huge, okay? So then we get this thing back. If you're an old hand at Power Query, you know exactly what to do next. If you've watched my videos on Power Query, you know exactly what to do next. If not, don't worry. You probably should have watched my videos, but you know.
Channel on YouTube.
Yeah, I won't hold it against you, okay? So what we have is if we had multiple data frames that we created in our query, each one of them would pop up here, right? But we only have one data frame, so we're only seeing one row. So the name is the name of the data frame, and the table is an object that stores all of our results, right? So when we click, again, you never want to click on the link. You click just to the right of it to get your preview here. There we go. There's our linear regression results right there, okay? So now again, we're just previewing them down here. If we actually want to navigate to them, now we do click on the link. We wait till we get our glove, click on that, and there we go, right? So now we've got, again, this is not a statistics class unless everybody wants to be. You all can vote. If you want to, we can turn it into a statistics class. But we've got all of the different drivers, potential drivers of sales. We've got their estimated effect. We've got their standard error, which is super useful. Well, I don't want to talk too much about it because it'd be a whole 5-hour lecture. And we've got our p-value. The p-value is something you could probably use even if you don't understand statistics very well, okay? So the estimate basically means, so let's just use an example. If somebody's married, it means that they're on average going to spend an extra $40 at our company than somebody who's not married. If somebody's a homeowner, they're going to spend on average $7.70 less than somebody who isn't. If somebody, for income, every dollar somebody's income goes up, they spend about half a penny more at our stores, okay? That's what those estimates represent. Does that kind of make sense to people? Okay. The p-value means, hey, is this thing worth even looking at? So you basically want, again, statisticians, I know I could talk about this for hours, but here's a simple version. A low p-score means that it's probably not malarkey, okay? It means that it's not just a coincidence. It means that this result is actually probably meaningful. So I'm going to round this just so you can see it a little better. I'm going to round this to, gosh, I don't know, 6 decimal points. And click OK. I don't know if I can zoom. You know what I could do? I know what I'll do. Here, hold on. Give me a second. I'm going to close it up. I'm going to load these into a table. In fact, I've already done this, so I'll just use this table right here. Okay, I broke my old connection, but this one still works. Is this guy a little easier to read up here? Yeah. Let me increase the size a little bit. If I can, yeah. Okay. So basically what we mean is if you've got a low p-value, it's very likely that that estimate actually means something. If you've got a p-value above 5%, it's probably likely that you should throw it away. If you've got a p-value of 72%, odds are that estimate doesn't mean anything. That's a 10-second statistics lesson for you, okay? So what this basically means, what this actually tells us is that in terms of marketing, income actually has a pretty solid connection. And so we might want to market more to people that make more money. It also tells us that people that are married, it's not an incredibly strong connection, but it's probably on the precipice of whether or not we think it might be a good statistic. So we might spend more money on marketing to people that are married so we can make more money for our company. Okay, does this make sense to everybody? Does that sort of whole pipeline make sense to everybody, how we did everything? Yeah?
One question I have is the development of the R script itself.
Yeah, sure.
Would you want to do that in our studio and then copy it over here?
That's probably how I would do it. What I would probably do, depending on the data, and that's a big if, right? If I think 1 month is pretty close to another, I would probably export it as a CSV, then work off of that in RStudio to get my script right, and then copy that script into here.
Okay.
That's probably how I would do it. Yeah, question?
If you have an error in RStudio, depending where your error is at, does it go over here?
I'm sorry.
If you have an error or some mistake in RStudio, it tells you where your mistake is.
Oh, geez, I don't know. I think, no, I think it's just going to tell you it didn't work. Yeah, sorry. Yeah, that's, again, it's one of the trickier parts of working with R. Question or comment?
Yeah, question. So in R, you created the linear regression model using the sample data that you pushed into it, right?
Yes, the very realistic sample data.
Right.
Yeah.
So once that model's created, if you wanted to apply it to another population, another chunk of data outside of it, is there a way within Power BI to apply that linear regression model to
Maybe query parameters.
Yeah, you might be able to do something like that. I mean, like if you could actually just extract the numbers themselves and sort of do it by hand, but that's probably not, that's a less fancy solution. For something like that, you'd probably want to use that first option where you're doing all of the data loading in R. That way you can load from multiple sources. Because right now, as far as I know, that function that lets us do it mid-query won't let you pass in multiple tables, unfortunately. Yeah. Yeah.
One other thing to look at for 19 is Visual Studio has an R plugin. Search for art ES, and it does do their intelligence with R syntax.
Yeah. So maybe I'm biased because I haven't spent as much time working with it. I find that R is less forgiving in terms of errors and things like that. Power Query is nicer. That's why I like working with Power Query. Yeah. Any other questions? Yeah. Oh, sure. And this, I mean, I'm working up a CSV right now, but you can imagine this is pointed at a SQL Server site, and you could set up your Power BI report to refresh every night, and it'll rerun that analysis every night. No, they'll both do that. I mean, so
So you're really applying different R engines, the execution can go through this at one time, whereas running, pulling up the data, so you're exporting it at that time.
No, so I mean, what'll happen is like, so with the top solution, right? Every night, Power Query will send an R script to R saying, go reload the data and go reprocess it.
Query SQL Server.
Yeah.
Based on those first R rules.
Right.
Whereas the next SQL Server is that.
Yep. Yeah, so it'll happen every night.
Whereas if it's second option.
So if you do the
Then you're applying to that existing data set.
well, no, because the thing is with Power Query is going to still refresh it every night. So Power Query every night is going to reach out, get the freshest data, suck it in, and then push it out to R. Is that,
Or every hour if you like.
or every hour if you like, yeah. Does that answer the question? Is that?
I'm just still looking at the previous.
Oh, sure, yeah, I mean, again, the big one for me is that Power Query has so many good connectors that you don't have to do anything with. They just work. That's a big reason. And otherwise, it shouldn't draw a big distinction. Yeah. Okay, questions before I jump back to PowerPoint? Because I know you all miss PowerPoint. Yes? Okay. Let's jump back to PowerPoint. Okay, so how useful are these things? Well, they have a ton of possible power, but they require a fair amount of knowledgeable statistics and R. If you don't know it or you don't know somebody that knows it, I don't really know how useful it's going to be to you. That doesn't mean it's not powerful. It just means it does have that requirement, right? And a lot of times, you're going to want to make sure that your end user knows something about statistics too, because if you send your end user a bunch of standard error figures, they don't know what that means, right? So, I mean, maybe if they're smart, they're sharp, maybe you can explain it to them and maybe it's useful. But again, that's just one other hurdle you have to get over. Still very, very powerful, but the number of use cases I think is a bit more selective, okay? So, big question, do you have a stats and R expert on hand? If yes, this could be a great option. This could be something you can get a lot of power out of, okay? So, let's talk about what I really came here to talk about, what I'm really excited about, using R as a visualization service, okay? So the R as a visualization service is for when the included charts just quite don't fit the needs that you've got. It's not as easy as using the internal visuals, but it's still fairly easy, right? And here's the thing I really like about using, oh, you know what I should do? Hold on. There we go, much better. The thing I really like about using R visuals is that they're much better at producing visuals that are dense. And by dense, I mean most of the Power BI visuals you can look at, and within half a second, you can glean all the information you need, which is great, But then if you look at it for another 10 seconds, you don't get any additional information. The visuals that you can create in R tend to be data rich. They tend to be dense. You can look at them for 10 seconds, for 20 seconds, and be like, oh yeah, look at that. Oh yeah, look at that. Oh yeah, look at that. And that's actually really, really nice. It means you could see a lot more data. You can see a lot more information. Very, very useful. Okay?
That's part of why I was harping at the beginning. It is, there will be a user education element. You're going to have to sort of explain, especially if your business users are not statistically oriented or not looking at charts like that. But once they get that, they can make so many more decisions out of one picture. And that's the whole other thing is the simplicity and elegance of the design of your tools can go way up.
Yeah. I mean, I think a lot of times with Power BI, and you can correct me if I'm wrong here, that a lot of Power BI visuals rely heavily on slicers, which is not a bad thing, it's just a thing, right? It's cool that you could slice and dice, but with one of these R visuals, you could just have one single picture that contains kind of everything, which is pretty cool. It's not going to replace Power BI visuals, but it's a nice thing to have in addition to them, right? I'm going to drink some water because I haven't done that yet.
It seems like we're seeing kind of an evolution going on both in the sophistication of users and in tools. And in the kind of the first generation of BI tools, it was all about dumbing it down. Because we know that users are dumb, right?
Right.
So we need to put things in simple charts so that they understand them. But you know, I think that now we've graduated to a level of sophistication where I don't want to just see a bar chart.
Yep.
I want to see a scatter plot, or I want to see something that has that depth. So sure, I want to take the 5-second look at it, but then I want to study it. I want to look at outliers and things like that.
Totally.
The only thing I will add to that, though, is that you can drill in a Power BI thing. You can drill down to exactly, so there's some really great use cases. I may see this fabulous chart if I wanted in an R chart and have to hop over to another page to get down to the drill functionality. And also he'll talk about the cross filtering. So, you know, it depends on how you want to interact with the tool. And is this a 60,000 foot overview decision making tool, or is it really just a drill to who did I lose this month?
And just to speak to that, Paul, because I think that's a really, really good point. Like, one thing I think that people are finding is it used to be that users wanted a chart that they could understand instantly, right? It required no training whatsoever, because that's nice. It's like, well, I don't have to learn it at all. But the thing is, all the charts that require absolutely no training don't tend to provide that much information. And if you're a decision maker, you don't want to be clicking from page to page to page, from slicer to slicer to slicer. You'd prefer, if you're looking at this report every single day, to have one view that contains all this information. I think it's actually really nice. It's worth spending an extra 10 minutes to learn. So.
The funny thing I've seen in my experience is that I get approached by business managers telling me I want X solution for all my factories, but they have no clue what they really want. But a tool like this lets us design the nuts and bolts that we can then design a high-level visibility of.
Absolutely.
It's huge.
Yeah, that's absolutely. Yep, totally. Okay, so let's look at some examples of things that you can't really do with the standard charts. On the left, we have I wouldn't call it a bad chart, because I think this isn't a one is better than the other, but here's a traditional chart where we've got all of our different subcategories of products, and we've got the total sales for each one. And it's fine, there's nothing wrong with it, but you look at it, 1 second later, you're done looking at it. There's not a lot of detailed information you're going to get out of it, right? If we look at the strip chart on the right, we've got every single product that we sell represented on this chart, okay? And we've got it broken down by all the different product subcategories. So not only can we see at a glance how our different subcategories are doing, we can glean out some interesting information about these different subcategories. Like, we can look down on projectors and screens. Like, let me go here. We can see these clusters of sales that we wouldn't see in an average or a total. And we could say, hey, some of our projectors and screens aren't selling very well, but some of them are. Can we find out which ones are and which ones are not? Can we get some of the ones that don't sell off the shelves and make room for ones that do sell? That's the kind of thing that you're going to get from a visual like this that you just won't get from a very simple aggregation. Questions?
So actually, that's an interesting question. We were just talking about being able to build down. That's an excellent example of where, gee, that's interesting. Some products are selling well, and like index impression would be, will be built down.
Yeah.
Like that.
Next
No,
time
you're right.
over, buddy.
No, you're right. I mean, and that's the bummer. Just to make sure everybody understands that. If I click on one of those bars in my Power BI visual, something happens. If I click on one of those dots, I don't get to drill down and see what that product is.
You don't even get a mouse over, do you?
You don't get a mouse over, you don't get anything. I mean,
explain to users.
yeah.
So there's something interesting going on here. Wouldn't you like to know?
Yeah, the real trick is before this conversation happens, you have a second page that has tools that let you drill down. That way when they ask you like, oh no, then we come over here and use this special tool for drilling down. Yeah, I know, it's not as good. But again, like, it's an imperfect world, and I think this is a nice thing to have in your tool belt, okay? So let's look at one other example of something that you can't really do in Power BI. We're gonna look at small multiples, okay? Or also called trellis charts. It's also called faceting in R. So if you look at like a regular old line graph over here, the stuff on the right, sort of the top right corner, works okay. We could see our sales over time by these different categories. But if you go over to the left, once those lines start crossing each other a lot, if you've got more than 2 lines, you can't see anything. It's a mess. And if like that stuff down at the bottom, those products that don't sell as much as other products, we have no idea how they're doing. We can use a small multiple to look at each individual line and sort of see the behavior of that line, like all at once. And we can also add trend lines, each
Yeah,
one.
that's what I wanted to jump.
Yeah.
The trend lines, we actually use this for one of our clients that were after the trend lines. You can't do a trend line in Power BI that way, or you can do it in certain, what's
Yeah.
that?
Multiple trends.
Yeah, you can't do multiple trend lines that way, and you can get it all in one, the comparative picture of it. So that was a really powerful chart for us.
Mm-hmm. Another question, yeah.
So what I thought is all these visuals are in R, platform.
Yeah, we're sort of doing, I wouldn't call it a goofus and gallant, but like sort of something like that. We're like, here's what you could do before. Here's what you could do with R. So the one on the left is a traditional visual, and the one on the right is the visual in the R. And that's the same thing over here. The one on the left, super easy to do in Power BI, and not a bad visual, but the one on the right, you could do in R, and I think it's richer. Okay?
And we're going to show you in a minute, you use a certain package to build the one on the right, and you have to write some code.
Yep. Yeah, so I would...
You don't have to do with the one on the left.
No, you don't, which is, again, it's harder to do. I don't know, you guys know Edward Tufte at all? You guys ever heard of that guy? He's a data visualization guy. He's got some really good books.
He was just here.
He was, yeah. That was a good, I didn't see that conference this year, but I saw it last year. Did anybody else see that conference? Did you get a chance to go look at it? Or?
A few years ago.
A few years ago? Yeah, so he's a data visualization guy. He harps over and over again. You want your data to be rich, to have data, density. So these are the kind of charts that make Edward Tufte happy. That's how I think about them, okay? If you want to, I've got a bunch of his books over in my cubicle. I'll show you after the presentation. I love showing off those books.
Hey, quick question, you may cover this
Yeah.
later. Can you recommend a playbook or a catalog? I mean, there are a lot of books that show our visualizations. Or
Yeah.
Lots of, I mean, I've got, 25 books in my library that have various visuals, but as kind of a go-to to sit down with users and say, pick something that resonates with you and use it as a starting point.
That's a fantastic question. I don't have that resource. Do you have something?
One thing is, and I meant to show it on mine, there's actually, for GGPLOTs too, which is what we're going to say is must-have for doing, there's a cheat sheet it's really great. It just shows you all of the, a tiny little cheat sheet that shows you all the different options with, and I love that. So I have the link to that. I can send it to you.
Maybe you'll put that up on the
I will,
website.
yeah.
Yeah, I'm trying to think if there's like just a gallery, because that would be fantastic. I see what you're saying, but nah.
Everyone would have their own.
Yeah.
Probably hard to consolidate.
Right. Okay, so.
It's an interesting point, Brian.
Yeah.
One thing I've seen is we're having statisticians come to us with Power BI because their visuals are too complex. We need to kind of go the other.
Okay, yeah.
It's because of this thing, like I can't click on something and get the data presented. And
Oh, sure.
Interacting that with slicers in Power BI gives them capability they've never had.
Right, yeah. And I think I should, two things I'll point out. One is, again, I'm not saying, this is not like a Goofs and Gallant thing. One's not better than the other one. They excel at different things. I think the R stuff is probably where I would have a user land and be like, hey, here's everything. I'm just gonna show you everything. Once you've found something you're interested in, then you go use the traditional R visuals to drill down and find deeper insights. Like the traditional Power BI visuals, yeah.
It is worth mentioning that our visuals do respond to filters. So if
Yeah.
you want to slice, you can do that. You just can't drill down. So you can still build in some interactivity with our visuals.
Yeah.
That's a very good point.
But you'll make this point, but you can't cross back the filter.
Right.
So he puts a filter on, and then I can't dive and say, okay, what does that which is one of the beauties of the other of Power BI.
I
So
think there's a comment over here too.
Yeah.
Yeah, I was going to say a good resource for visualizations is a guy named Alberto Cairo.
Oh yeah. Uh-huh.
You can get his books in Amazon, and it's not exactly a like picture version of Choose Your Own Adventure, but it's great to kind of understand what folks are going for,
Mm-hmm.
and giving you visualizations is really helpful.
Mm-hmm.
I'll throw out Nathan Yao's name as well. He's got some newer books.
Oh yeah. Okay.
He's up to 4 or 5 different books now. But he runs a site where he consolidates examples of visuals called DataFlow.
sorry, I just did
Okay.
some
Dataflow.com.
Uh-huh.
He's got a series of 4 or 5 books from Wiley across the grid.
Uh-huh. Okay, cool. Yeah, I mean, one of the tricky things with books that I found is you want to make sure that you don't show your user something that you don't think you can produce.
Right.
That's amazing. Can you make that? Hey, no, look at this. Pay no attention to that visual behind the curtain. Okay, any additional questions? Okay, let's keep moving forward. Decisions. Should you use our visuals? Well, the good news is there's lots of chart options that are simply not available with native Power BI visuals. These are extremely good for 30,000-foot views, seeing everything all at once. And this is going to be the easiest hard language you've ever used. Okay, so it's a language, you got to learn it, but it's not that hard. It's going to require some work. It's going to require some Google, but I've dealt with worse, I assure you. Okay. Weaknesses: there's no two-way cross filtering. If you click on a dot in a bar chart, nothing happens. There's no tooltips. If you hover over a dot or a bar in our visuals, nothing happens. You can't drill down either. You can't click on it and have something else happen. And also, obviously, they're harder to build. Those are all the downsides. Okay. Yeah. Not for a while. My guess. So here's my honest prediction with that. For the most part, they'll probably always be R, just because you can do anything in R. It's a programming language. A lot of the visuals that are just currently not available as native Power BI visuals will start to become available as native Power BI visuals. Those things are really hard to build. I've looked at even trying to do it. It's incredible that they get done at all. So they take a while to get produced. But that would be my guess. I mean, I don't know. Anybody else want to have thoughts on that?
My observation is the integration of R that's been done now, they've harvested the low-hanging fruit, right?
Yeah.
The way that it's integrated is like sort of the most simple, straightforward way they can do it. Going to the next level, making those R visuals sort of first-class citizen visualizations within Power BI, like native visuals, is probably a factor of 10 or 100 times harder.
Right.
So.
Mm-hmm.
But R doesn't have that capability, right?
Oh no, not at all.
Yeah, I mean, so we're asking for something that's not even capable of the application.
Yeah.
This would be a matter of Microsoft changing R, not just adopting R.
Right.
But they own their own piece of it now. They could.
One interesting thing I did read.
That would be Power R.
Power R. Ooh, that made me happy. One thing I did read that was interesting in the forward. So I'm gonna sort of jump ahead. This is the GGPLOT 2 book. It's written by the guy who actually wrote GGPLOT 2. In the forward, he talks about he's creating a new language that's designed for web, which has more interactivity built inside of it. I don't know what that means.
R sharp.
Yeah. Yes. Sure. Yeah. Exactly. So you might have solutions there too. But again, that's kind of stuff a little ways away. Question?
Does the R scripts they contain multidimensional visuals?
So GGPLOT 2, I don't know. GGPLOT 2 does not. I remember reading that in this book. There are other libraries that you can load up that do that. So yeah.
Power BI doesn't have multidimensional.
Like three-dimensional views? I can't think of any. Oh yeah, well there's one, and there's, what's that?
Isn't the old one kind of?
The globe visualization, and then
Sandance is the other one. Yeah. And I should mention, I was going to mention it in my last slide, but I'll mention it here. Some of these can be reproduced in Sandance. So that's something to think about. If you could do it that way, it might be better. Okay.
There's a book called Graphing Data in R by O'Reilly, and it has all the different R visualizations in it. And there's a lot of three-dimensional, multi-dimensional visualizations. Graphing Data in R by the O'Reilly book.
What you'll notice in the custom visuals gallery of Power BI, there's really two flavors. there are sort of third-party developers, and then there's Microsoft Research developers. Right, and the Microsoft Research custom visuals in the gallery tend to be more sophisticated generally, because you've got the Microsoft Research project that's funded, with what, $7 billion in their budget. So what seems to be happening is more activity from Microsoft Research in developing Power BI related stuff.
Mm-hmm. Yeah.
Like quick analysis, for data sets and Power BI service, another example.
Mm-hmm. Absolutely. Absolutely. Okay. Any other questions before I move on? Mind the learning curve. Again, we sort of talked about this. A good chart often is going to require a little bit of learning. It's not going to be like a simple activity. You're actually going to have to spend some time with the user walking them through, here's how you interpret this graph. It doesn't have to be a long 40-minute process. 5 minutes will often do the job. But just remember to do that. It yields some good results. So just to give you an example of A, what a harder chart or like a medium level chart might look like, and B, how you might explain it, we're going to look at a sales year-over-year scatter chart and how to read it, okay? I'm going to show you this in Power BI, but first I'm going to just walk you through how you read the darn thing. So this is an XY scatter, and we've got total sales for this year on the y-axis and total sales for last year on the x-axis. So what does all this mean? Well, each dot is a different product, right? And if a dot is green, it means sales were better this year than they were last year. If a dot is red, it means sales were worse this year than they were last year. But it's a little ahead of the point. Let's actually look at some of these, maybe it'll make a bit more sense. So let's look at this cluster up here, right? Let's look at this dot right here. This dot right here had pretty low sales last year, okay? But it has pretty high sales this year. This is a high growth product. In fact, all of these are high growth products. If we knew what these products were, we might go clear out some shelf space to sell more of these products. By contrast, if we look down here, the sales last year was very, very high, but the sales this year is very, very low. So these are products that people aren't buying as much this year than they were last year, okay? If we go up here to the top corner, these are products that are selling pretty well, but they were also selling well last year, so we might not have a lot of decision points around that. Does that make sense to everybody? Okay, good. So let's take a little field trip, because we've been looking at PowerPoint for too long. I'm going to click over here. Are we going to the ice cream store? No, we're going to go look at charts. So let's go to So here's that same thing, but with small multiples, okay? So I realize there's some people in the back, it's a little harder to read, but each one of these little small multiples or mini charts is a different product category. And each one of the dots is a product. So instantly, we could see in one single chart, every single product that we sell, we could see how they're grouped, and we could see if there's trends within different product lines, right? So if we come over here to refrigerators, we can see that we've actually got a big cluster of refrigerators that are selling pretty well this year. That's kind of interesting. I think if I uncheck North America, I get a better result. Give it a second. It's going to reproduce the image. Okay. If we come over here to washers and dryers, we see that almost all of our washers and dryers are actually selling not nearly as well. We might want to go look into that. That might be something that is actionable from our point of view. Another one that's kind of interesting is if we look over here at projectors and screens, there's a bunch of projectors that are sort of about the same as they were last year, but there's a bunch that are doing worse, and then there's this cluster up here that's doing better. Again, let's go find this cluster and see if we can't make more shelf space for it, okay? So that's an example of a chart that is not difficult to read, but if you just drop this in front of somebody, they would be like, I don't know how to read this. But in 5 minutes, you can hopefully understand it and see that this thing's got some actual value in it. It's got some actual legs. Okay, any questions? All right, back to PowerPoint, because y'all love it so much.
When those charts now, you
Yeah.
develop those how?
What's that? It was like,
You develop these charts how?
oh, just in R. This is just an R script, yeah.
He's going to show you how.
Yeah.
Using GGPLOT.
So we're not going to build this one because it's a little bit too long, but just so you guys could see what the script looks like. All right. There's a script. Is it 3 lines of code? No. Is it 500? No. Take an hour, maybe, with some Google. Not too bad for a really good chart, I think. All right. Does that make sense? Any other questions about that? What's that? Oh. Okay. No problem. I do that all the time. Okay, so we're done with our field trip. Our visuals. Our visuals are at play in 2 acts. There's 2 things you have to do with our visuals. You have to add all the data to be processed, then you have to write the R code to create the visual from that data, okay? So if we come over here, step 1, we have to drag values. We have to drag stuff into our values column to build the table of data. And then we're going to write a script to produce a visual out of that data. Okay? So let's review these one by one. To start off with, we're going to start with the data. This is something that's pretty tricky with people. They click on the R visual and then nothing happens and they get confused. Okay, so here's how you're going to do this. Here's how I recommend you do this. When you're going to create an R visual, don't start by creating an R visual. You're going to start by creating a table visual, right? You're going to create a table visual. You're going to drag the data you want to visualize into that table so that you could see it and be like, oh yeah, this is the data I want to work with. Then when you're done with that, you've got the data you want, then you click on the R visual button to start writing your code, okay? Does that make sense to everybody? Okay, because if it doesn't, I've got these nice pictures. So we're going to create a table. We're going to add the data. We're going to look at it and be like, oh yeah, this makes sense. We've got each category, and for every category, we've got all these different months, and for each month, we've got the sales. Perfect, that's what I want. Then you click on the R visual button and start writing your script, okay? So is it writing the script the hard part? Yeah, but it's not too bad. Let's take a look at that. When we talk about writing visuals in R, I, at least, am basically always talking about GGPLOT2. I consider it the crown prince of visualization libraries in R. It makes things very easy, but at the same time, is very, very flexible. There are libraries where it's easier, but they're more rigid. You can't do as much with them. GGPLOT2 is very, very powerful without being too hard, okay? It's based on the graphics grammar, which is a mental model for thinking about graphics. Again, other libraries exist. Don't use them, not to start off with. So how does writing an actual script work? Well, there's a couple phases. Pre-game, when you're actually writing the code, you're going to write a little bit that says, load the GGPLOT2 library. You're going to define your canvas. You're going to say things like, what does the x-axis mean? What does the y-axis mean? What does color mean? Then you're going to say, hey, what kind of shapes do I want to have on this chart? Do I want bars for a bar chart? Do I want lines for a line chart? Do I want dots for a scatter chart? And then when you're done with that, you're going to clean up the layout by using themes to say, hey, I want to make the background this color. Hey, I want to make the fonts this size, that kind of stuff. I know I haven't shown you any code, but does this make sense? Yeah? Okay. So here's the finished project. We're going to go through it one by one for a very simple visual. To start off with, we're going to load the library. Very easy. Library GGPLOT2 says, hey, we're going to work with some of the functionality in GGPLOT2. Then we're going to define our canvas. So
Just as a distinction, that's after you've downloaded the package. Okay, so you've got to download the package.
Right. It will work far less well without the package.
It doesn't work too well without the package.
So we're going to create our canvas with GGPLOT. The first argument is what data are we going to work with? Whenever you send out data to a visual in Power BI, the data is always called dataset. You're always going to type in dataset. AES stands for aesthetics. What do the different aesthetics mean? What does the x-axis mean? Oh, in this chart, the x-axis means the calendar year number. Oh, the y-axis means total sales. Easy as that. Okay?
Those are just columns in your data set.
Yeah, just things you're bringing over. Yep. So you're mapping data in the data that you're processing to some aspect of the canvas.
And that's what they call them names.
Right. Exactly.
One thing I want to point out that is super confusing until someone tells you, those are not apostrophes around the.
Oh yeah.
Those are that's the accent grave, which is above the tilde.
Oh, no wonder that.
It's a really important thing that you will like bang your head against your keyboard until someone tells you.
Yeah.
What is it again?
The accent grave, which is, I always remember it as, yeah.
No one ever used that.
Well, I think they just felt bad for the character. Yeah. They're like, you mean I get to do something? Yeah, Grav, you get to do something. Yay! Okay. This makes sense, everybody? Good. The next step is very complicated. We're going to add a line. It's as simple. We're going to add a GEOM line. And there, if you look on the chart, we've added a line to it. This is before the line.
Geometric form, basically.
Yeah, some shape. Something that you can see, right? Then when we're all done, we're going to clean it up by using an out-of-the-package theme called Theme Minimal, which is just going to change the background color, basically. Okay? And that's that. Let's look at each section a little bit closer, shall we? Using aesthetics, again, all we're doing is saying, hey, what does the x-axis mean? What does the y-axis mean? If things are going to change by color, like what does color mean? Like if we think of like a scatter plot, we could have color be region. So each dot represents like what region a person is from, right? If we talk about like the number of children is size. If a dot is bigger, that means that dot has more children. It's a customer, presumably, right? If we talk about shape, we could say, hey, we want the shape to map to gender. So like different genders have different shapes associated with them. Does that make sense to everybody? Okay. GEOMS, again, these are just the actual like elements that you add to your chart, and they sort of work the way you think they would. Geom line means you want to add a line chart. Geom point means you want to add points for an XY scatter. Geom bar, I want to add a bar chart. Text, I want to add labels. Smoothing is not as obvious but really awesome. That's if you want to have like a trend line, and it can be a linear trend line. It can also be an exponential trend line too. Very nice. And if you're a big stats nerd, you could add things like box plots to look at distribution.
So there's some aesthetics applied to some of these colors, like shape on a line.
Yeah, that makes sense.
But size would.
Yeah, and that's the idea, is that you define it for the canvas, and then each one of these shapes inherits it from the canvas itself. We think sort of programmatically. Yeah. Okay. And you can override it too if you want to. Are you restricted to having exactly one geom per chart? No, stack them high. In this example, we've got both a jitter plot, which is sort of all the little dots, and we've got a violin plot, which is sort of the distribution bells. Okay, they play very well together.
There's a question in here.
Oh, question. Yeah, yeah, yeah.
So I assume there's a lot of like templates involved here, right? Like text size and font.
Yeah.
And all that, right? Can you define that somewhere template?
That's what you generally do in themes. Yeah. Sometimes you'll do it in the actual geom itself. Sometimes you'll do it in themes, depending on where it is. Yeah. But yeah, you could override pretty much everything. Yeah.
Related to that, though, when you're publishing the Power BI experiments, you probably can't change the process that.
Oh, sure.
Right?
Oh, yeah, yeah, yeah. Uh-huh. Mhm.
I would know one thing, unless something has changed in the last month, you cannot change if you're doing like if you have time on your x-axis, you can't change the start and end points at that time. Power BI can't do that itself.
Yeah.
You can't manually set those. So if you only want to see on 4 to 17 on a vertical axis, you can't do that. You can do that through. So I'm not sure if you can do that in Power BI, but that's one thing that you can do if you're working just in R.
Yeah.
It won't work here.
Okay. Yep. Yep. Okay. So so themes are what you clean up with. So you generally create like your chart, and it's usually kind of ugly to start off with. You have to clean it up with themes. You're going to change the background color. You're going to change the lines on the chart. You're going to change the font color, things like that. Some themes are insta themes. You just apply them, like theme.minimal has a bunch of stuff already baked into it. So we could change, like, we could call theme minimal and it'll look like that. We can call theme dark, it'll look like that. We can call theme void, it'll look like that. If these work for you, they're great because they're a single line of code. If you don't like them, you could change it element by element. You could change the background color. You could change the x-axis title. You could change grid lines. It's all pretty easy. Okay.
You apply one and then do that.
What's that?
You apply theme minimal and then do it.
Yeah, absolutely. So you can override it. Yeah, absolutely. In fact, that's usually what I do. Okay. So we're going to do, I think I might do a compressed example because time is sort of becoming an issue at this point. I don't want people to not get out of here before they fall asleep. That's ideal, I think, in a presentation. I think I read that in a class somewhere. But maybe what I'll do is I'll show the first couple steps to one, and then I'll leave some of the fancier stuff out.
And, Brian, this presentation will upload it to the meetup site.
That's right, yeah. So we're recording it. Yeah, we should just upload it straight to the meetup site. So if you got to go, you should be able to watch it at home. Yeah. Okay, so let's go look at.
One thing I want to say before he does this, what he just did, what we're going to do is actually, don't underestimate the time you're going to spend screwing around with it. Because if you get it right, it's not exactly going to tell you, oh, there's the graph accent that you put in wrong.
Right.
You really can spend a lot of time. It's fun because you can, get pretty cool stuff by adding different things, etc. But it can take a lot of time.
Absolutely. Okay. Okay, so we're going to build part of this graph. So again, step one, you don't click on the R, you click on the table visual to populate the table first. That way you understand what you're sending to R. So we're going to create, well, what we're going to create is this guy right here, okay? So what we want is we want all the product codes, we want which subcategory they belong to, and what their total sales is. Easy, okay? So we're going to go up to product. We're going to find our product code, drag it in there. Hey, check it out. It's all the product codes that created its own table. Oh, that's a little silly. Whatever. Sometimes it works for you, sometimes it doesn't. And usually when it doesn't, it's because you're presenting. Let's see. So we're going to go find the product category, right? Or subcategory. And my mouse is just not working at all today. So there we go. Create that. Then we're going to go down to sales and grab total sales. Okay, so we're going to delete this, not quite a chart. Again, first thing we're going to do is make sure, hey, does this make sense? Yeah, for each part of code, we've got the subcategory and what the total sales were. Perfect, that's what we want to visualize. Now we're going to click on the R visual. We're going to get nothing here, which is disconcerting. And we're going to get this little thing down here. We're going to twirl this open. Hey, now we can write our R visual, okay? So I'm bringing it down here so you can actually see some stuff. Okay, so again, we're just going to focus on some of the simple stuff. We're going to start again by misspelling the library. That's critical in any visual that you produce. So we're going to start by calling the GGPLOT2 library because we're going to need it in a second. In 1 second, yes. See, right there. Now we're going to call it GGPLOT, which would not work if we hadn't called that library. So what data are we working with? Well, we're going to work with data set, okay? And now that we've defined that, we're going to define our aesthetics. What does the x-axis mean? What does the y-axis mean? So you don't actually have to type in x and y for the first two. It just knows by default, but I like to be explicit. So we're going to say the x-axis corresponds to total sales. And I've been misspelling this all day while I go through this example, so hopefully we get it right this time. I keep saying total sales as opposed to tote sales. Yeah, that's fine.
Quotes have to be...
You need the graph symbol here. Yeah, quotes will not work. So the graph symbol is the symbol that's being held down by the tilde because it's trying to escape. Okay? It's a little keyboard joke right there. And you're looking at your keyboard. It'll hit you later on in the evening. Okay, so we got our total sales on the x-axis because that's what's going to float along the x-axis. Well, what's on the y-axis? Well, that's subcategory. Oh, yeah. See, I'm glad you guys are all here. And I'm getting kind of tired. Subcategory. So y equals subcategory. Okay. So, and subcategory, it is case sensitive. We have to have it like that. Again, since there's no spaces, we don't need those little graph symbols. And we need to close out. We've already closed out the aesthetics call. We're going to close out the GGPLOT call. Now when we hit run, we get a very boring canvas. Right? Hey, check it out. It's a thing. Let's look at the thing. We're going to make the thing bigger so everybody in the back can see it. Run it again. Amazing. I think we're done. No, wait, we should do some more stuff first. So we need to add our geometrics. So we've defined our canvas, but we haven't added any actual geometry to it. So let's go ahead and do that. Okay? So let's do, and this is also kind of a funky thing about R and GGPLOT. Rather than wrapping functions within each other, you just add functions to each other. And that's just sort of how it works. So we're going to add a plus symbol to say, hey, we've done this function, we're going to add something to it. We're going to stack these functions on top of each other. A little weird, but it's okay. It actually is kind of nice once you get used to it. So we're going to do geom underscore, we're going to start with a point, just so you guys can see it. So now when I hit run, we've added geometric points. Boom, there we go. See, not too bad, right? Okay, just so you guys can see it, we can also add a line, which is again why this kind of GG, grammar of graphics thing is nice, because it's very easy to switch between geoms like that, okay? But we don't even want lines or points. We want what's called the jitter, which is basically a point, but it shakes it up a little bit, so if dots are falling on top of each other, you can see them. So we're going to do geom and jitter. And I'm going to actually add a couple parameters right now. So we're going to do the width of the jitter, how much we want the jitter to be side to side. We're going to do 0.00. How much do we want it to jitter up and down? Well, let's see. What did I figure out earlier? I think it was 0.3. And we want the color to be blue. And we want the alpha, how transparent are each one of these dots, to be 0.3. After the blue? Yeah. Sorry, it's been a long day. I'm getting tired. Okay. Any other typos? You get bonus points if you point them out. I think that should be everything. Okay? So now we've got that. And I'm going to add a theme minimal. Theme underscore minimal. And I'm going to hit run. Okay? So now we've gotten most of the way there, right? So let's see, what time is it? It's 7:43. We're way over time. So I think the most important thing whenever you're producing an R visual is to have it pre-written in a text file. So you can just suck it up and just kind of cheat basically. Yeah, we'll need the plus sign.
But
so.
actually, in a way, that's a little bit true because once you get some of these you like, you can just start reusing them all over the place and just apply the different metrics you're actually
Share
trying to
of
capture.
freedom.
Yeah, like Pokemon.
Copy and paste.
And along those lines, if there are colors that you're using to kind of brand everything else, you can store those colors as hex codes and reference them in this script so that it can all match up with the rest of everything you're producing.
Absolutely, yeah, that's a very handy way to do it, which is also pretty hard to do in Power BI. Okay, so while you guys were listening to that comment, I wrote all this stuff. I know, I'm pretty fast. So basically what it is, I added a theme. So
It's better if we don't lie.
yeah, it's true. So for the major y-axis lines, I've created a color called gray 95. I made a color of 6. You're going to notice when you see this little tiny line here is going to turn into a big channel. The sort of up and down marks or up and down lines I got rid of by changing it to an element blank. I'm going to change the labs, which is the label, so I'm going to change the title, and I'm going to get rid of the X and the Y titles, and I'm going to call this library called scales, and when I do that, I'm going to call scales X continuous label equals $. That sounds confusing. All we're going to do is just before I hit run, usually your decision makers don't want to see their total sales expressed in some sort of weird Frankenstein scientific notation. They prefer things like $1,000. So that's what that's going to do. Run. I know. Some people just don't understand how the world works. Okay, and that's that. All right? Great. Thank you. Thank you very much. Again, absolutely critical. Have it in Notepad ahead of time. Other questions? Yeah.
Can you sort that?
You probably can, but I don't know how to do it. So you could always do a manual sort by saying, show these categories in this iterated list that you write by hand.
What if you sorted your table in advance?
That's what I was wondering before you sent it, if it would come back.
I think it probably would do it that way. Yeah, I think it probably would. It would just sort of respect that. And again, yeah, if you got to take off, this will be online, so apologies if I'm running a little bit long. Question, yeah.
Yeah, so I've read the documentation. One of the limitations is you're limited to 150,000 data points.
Absolutely, yes.
All right, and what happens when I add 150,001?
So according to the Microsoft documentation, it'll produce the chart with the first 150,000, and that last sad data point will just get ignored.
Okay.
I feel like I've tried it in practice and had it just not push those other points up and not tell me that it didn't do it. So I wouldn't rely on that error message. Again, we'll get to this in a later slide, but this is amazing for summarizing dimension tables where you're going to stay under that $150,000 mark. If you want to summarize every transaction your business has ever had, if you've got a small fact table, that can be awesome. If you've got a big one, yeah, you're kind of out of luck.
Dumb idea. Couldn't you just do it twice and lay one on top of the other if you had more than 150,000?
You could. It'd probably require a little bit of work to get it to work correctly, but yeah, you could do something like that. And you could always, just filter the fact table down, just sort of inherently filter it down in some way. Yeah.
There's a question of should you.
Just brainstorm.
Yeah, you could. Yeah, it's not possible. Yeah.
Brian, something
Yeah.
that our stuff is that so if you use your Italy on the right or pick one of your.
I'm going to go with Japan. I'm a big fan of Japan. So when you click it, boom.
And then what we've also done is taken at the bottom, we talked about not having drilling, but we actually put an incredibly small data table with 3 or 4 rows.
Oh, really?
That you can expand out and export out to Excel or whatever the hell you want to do.
Oh, that's clever.
But we put it in with pretty much every field they might want to possibly see, and then they can use a visual filter to actually drill and filter for VCR, DVDs, or whatever it is that they want to see, and then they can isolate those.
Okay, yeah. Absolutely. So that sort of falls into the category of have a secondary tool for your,
Well, instead of a second tab. I don't
But
want
it's, not a second tab, yeah.
Again, I want to just show them a little tiny bit, hey, there's enough data here, and it responds to all your visuals.
Yeah, it's pretty clever. Yeah. So I've tried to do it before, and I just never could quite squeeze both on there, but that's actually a really good way to do it.
Just give them 3 rows.
Yep. Yep. Other questions?
I noticed in the R script when you're referring to the fields, there's no table reference. If you had a conflict in a field name, could you specify the table?
You can. I know there's a way that you're not supposed to do it that I understand, where you put the table and then the $sign and then the column name. Matt, do you know if there's I feel like I read somewhere there's a better way to do that, or if that's just fine?
That's the only way I've ever done it.
Yeah, I think maybe I'm thinking of something else. I think it's So
Well, you only send in one data set, so
yeah, I mean, like if you had a column called GGPLOT or something like that, I don't know, you know, something that's reserved by the system or used by a library or something like that. Yeah, yeah, you have to be specific about it. Other questions? Yes.
You mentioned that you have to download some R packages and everything. So does the R engine use that as well separately, or is that distributed with Power BI?
So when you're working on desktop, when you're developing on your personal computer, you need to actually download R and have it running on your personal computer, which is easy as just installing it.
How about your users?
So when you're using the service, it's actually going to be calling R that's sitting on a server somewhere. You don't have to do anything, which is great. That's my favorite thing to do.
Can I ask a follow-up question to that?
Absolutely.
Is there any relation between the Power BI R service and Windows R server and the new R tools?
Yeah, I wish I could say I knew a ton about that, but what I do know is that Microsoft owns a flavor of R, and they've produced their own. And the nice thing about it is it's optimized for working with very large data sets, which your local instance of R is not. So not only can, like, as I understand it, R is sort of memory bound. If you've got more data than you've got memory, it just can't work with it. The server version, if it's got more data than it's got memory, it'll just break it up into chunks and do one chunk at a time. Also, it's got some nice linear optimization stuff, so like linear algebra stuff. So for a lot of regression analysis, it'll work a little bit faster. That's about all I know about that. Other questions?
One of the queries, everything you're doing here in Power Query means that it's not capable of direct query, it's only with import.
I think you could do direct query sometimes, but not others. One of my final slides will talk about the different places it doesn't work. Yeah, but I think it works with regular direct query. Yeah, I think so. Yeah. Okay, hey, you know what everybody loves is PowerPoint. Let's go look at PowerPoint. Okay, I'm going to skip the second demonstration because I think you guys got the basic idea there. There are some terms and conditions. Again, 150,000 row max for visuals. So if you want to summarize dimension tables, oh, beautiful. If you want to summarize fact tables, better hope it's a small fact table. Drawn in 60 times 5 seconds. There is a timeout. If a visual takes more than 5 minutes to process, it basically just gets lost. It goes away, falls into the ether. I don't know what happens to it. It needs some sad end. You could do one-way cross-filtering, but not two-way cross-filtering. Already talked about that. No tooltips, no drilling. Also, if you're using a time data type, apparently that doesn't work in R, so you have to convert it to a date-time data type. Also, I found for the if you're using the transformation service, it doesn't even like time at all. When you try and import it, the time will just be like Microsoft.ode.time.object or something like that. So you have to convert it to text and then just recast it when you're in R. I should have put on my nerd hat before I said all that. But again, you won't have to deal with it that much. Places it doesn't work. It will not work for publish to web. That may change, I don't know. It will not work for printing. It won't work for direct query mode of SAS, which I think implies that it will work for direct query mode otherwhere, otherwise they wouldn't have qualified it. It also will not work with Power BI embedded. My guess would be, like a lot of things Power BI embedded, that's a new service. There's a lot of things that just aren't turned on yet. Maybe they have no plans to enable it. I kind of doubt it, but I don't know. I'm not Microsoft, but I don't. That's just my guess. Anybody else have uneducated guesses, which are my favorite kind about that? No? Okay.
Clarify point
Yeah.
one. It works in the service, but you said it doesn't work when you publish to web.
Yeah.
It runs in the service.
Yeah. So if somebody logs in and looks at the visual that way, it works just fine. But if you publish it to a web and you just use an embed code.
Oh, okay. All right.
Yeah.
All right. Big embed. Big embed.
Oh, I'm sorry, no, small embed. Small embed. Yeah.
Got it.
So yeah. But and my guess would be that they're probably concerned that if they post something out somewhere to some public website, it'll get 10 trillion clicks, and it'll crash their R server because nobody's paying for it. This is my guess. I don't know. I don't know. Hey, only certain packages are supported. Well, there's a short list of packages that are supported, and it's all these. So a lot. GGPLOT's in there somewhere. I don't know. Yay. There's also more in the pipeline. That Broom package. So when I did the linear regression and I pulled the results, I used that Broom package. So I can't actually do that yet. This is on the short list of things that are coming. So you'll have to wait a little while before you can use Broom to extract results from a regression. Okay?
And with the supported packages, nothing to install, these are all just inherently.
Yeah, they're installed. Yeah, absolutely. It's probably a good idea. Well, yeah. So when you're working on your local instance, when you're developing, you want to install them, obviously. But yeah, on the server, you don't have to do anything. But if there's a package that they don't have, you can call Microsoft and ask them to add it, and that's about it. So, you know, you've got your list, and that's sort of it. Yeah, they'll get through it the next day. Yeah.
Can you develop in the service on ARM?
What's that?
Can you develop in the web on the service on ARM?
So you might develop your own packages? Is that,
So, you know how you can use your service environment as sort of a dev environment? Could you do that with R?
oh gosh, I don't know.
Or is it pretty much only probably deploying desktop and then deploy to the service?
I think that's generally how you do it, but I'm not sure. I'm not sure.
You don't really have Power Query in the service per se. You don't really have Power Query in the service.
Yeah. Okay. Do you got to catch them all? Do you need all these things? No. You only need a couple that you're working with. I think if you don't get GGPLOT 2, I have failed in my job as a presenter today. Great shame will fall upon me. GGPLOT 2 is fantastic. You should definitely get that. Scales is great. Scales converts that scientific notation to actual dollar signs. And Broom, again, it's not there yet, but it'll help you extract data from linear regression, things like that. In order to use visuals in Power BI, you do have to be an enabler, unfortunately. When you first use them, you have to click on the Enable Script Visuals thing, and you click that little button there. I did try this today. If you use it online, it looks like your user doesn't have to click to enable it, but they do get that warning, just saying, hey, this contains our visuals. FYI. Final thoughts. We finally hit the finish line. For loading statistical information into your data model, there's a lot of potential, but there's not as many use cases, and it requires sort of a lot of knowledge. For visuals, by contrast, R, particularly GGPLOT, opens up this entire universe of possibilities. I think it's definitely worth learning, because you can get a lot of stuff done. You can produce some very dense, very beautiful, very Edward Tufte-y, happy-making visuals. R visuals are not always better than native visuals, but they're fantastic to pair with native visuals, so it's good to have them in your arsenal. Also, don't forget about things like Sandance and custom visuals. Sometimes you might think, hey, I have to do this in R. Go check to see the custom visuals. Maybe they can handle it. Okay? If you want to know more, GGPLOT 2, amazing book. You can come look at it when we're done. There's a trillion books out there for different R uses. And also, looking for tutorials, gosh, there's a bunch. Just Google it. You'll hit about 1,000. Okay, so I know you have questions. Or maybe you don't. I don't know. Does anybody have any additional questions before we saunter off into our next segment? Yes?
Within the visual script, can you continue to process no data, no transformation?
Oh, yeah. Yeah, so one thing you could do, one thing I've thought about, I mean, I don't really know enough statistics to make it super duper meaningful, but you say you could load a time series, like a line chart of sales over time. You could actually do like a forecast in your chart and create a forecast chart, basically. That's something that you could do. Yeah. Other questions? So yeah.
On the topic of using statistics and choosing the correct statistical models, do you think that the linear regression is pretty standard for what is used in Power BI, or is there a point where you might be investigating different regression models?
My real answer is I don't know enough statistics to really sort of give a solid answer. The one thing I will say, the linear model is probably what you want to use if you know a little bit about statistics, but not a ton. It's when you start choosing these big fancy models that you have no idea how they work that you can get yourself into trouble. The nice thing about a linear regression model, it's actually reasonably easy to like read and interpret, and you're not going to make a bunch of silly mistakes. So in that sense, I probably would predict it if you choose it, just because it's simple and it makes sense. Yeah.
Generally,